Well, hello, greetings. I'm Tim Kearns with the Great Lakes Observing System, and we're here today for a special live stream to talk about a missing plane. Lost in 1968, the plane took off from the northern shore of Lake Superior, and a team of researchers was on board. There was two researchers from the National Center for Atmospheric Research, as well as a graduate student, and they made a radio call. This was October 23rd, 1968, and that was their final radio call before they disappeared along the southern shores of Lake Superior. And now, this week, there is an effort to try to find that missing plane. It's not the first effort. When the plane crash happened in 1968, there was a huge search and recovery effort for it, and they were unsuccessful in finding any of the pieces. However, lots of debris did float ashore, so there was confirmation that the plane indeed had crashed. So now, 56 years later, there is another intensive search for it, and it begins today, this time using autonomous technology from the Michigan Technological University and partnering with a company called Ocean Infinity. They're using a vehicle called the Armada 8, and they are en route right now out to the survey site to survey around 20 square miles looking for the missing plane. Hopefully joining me today, I'm going to have a few people, one of whom is Travis White. He's a research engineer at MTU. He's on the crewed vessel, which is going along with the uncrewed vessel to search for the plane. And he's with a number of his colleagues as well, and I'll introduce them as we go. Just a little more context for all of this. This is all being led by a group called the Smart Ships Coalition, which is a group of technology, academia, research, private industry, other interested parties who are really focused on developing and cultivating and sharing technology and advancements in the Great Lakes, with a common interest to advance and protect the Great Lakes. Okay, it looks like we do have Travis online. It's great. You're clearly on a vessel, Travis, and we're great to have you on board, I guess, the live stream today. Tell us a little bit about who you've got with you and what you're up to right now.
Yeah, hey Tim. Well, glad we're coming in loud and clear from Lake Superior. We're currently about 10 miles offshore, and we've been on our first transit line to the primary search area, which is roughly 10 miles west of the Keweenaw and about 7-8 miles off ashore. So we're underway, and I've got a whole crew of technologists on board. I've got two colleagues from Ocean Infinity, Chad Bonin and James Jonikins. They are currently controlling and monitoring the ASV, which is trailing us at about a half-mile's distance currently, and it's doing a parallel line survey to our RV Soliton, which we're aboard now. I've got Anthony Arnold, a research engineer at GLRC. He's to my left, and he is monitoring the waterfall of the Norbit multi-beam acquisition coming off of the ASV. So we are Starlink to Starlink watching this data as it's being collected in real time, which is very cool. And then behind me, I've got my colleagues Jessica and Ali from Kongsberg, who are operating a different multi-beam system, 2040, on this vessel, pole mounted. So we're running parallel survey lines, kind of divide and conquer in what we would call a force multiplication scenario with the ASV.
That's excellent. So tell us a little bit more about multi-beam technology. I mean, what kind of water depth are we talking here, Travis?
Yeah, well, I am far from an expert, but I've learned a lot about it here in the last couple of weeks, thanks to the folks on board. We're currently in about 50 meters of water, and our core area that we'll be searching this week is 300 to 400 feet, or roughly 100 plus meters. So we've got multi-beam technology that is providing a very high resolution through about a half-degree beam separation, I believe, on each unit. So as we're moving at slower survey speeds in the 3 to 4 knots range, we're creating a very colorful image, literally, of the lake bed beneath the boat. And we're also watching a waterfall view that's very similar to what many folks are familiar with as sort of a side scan sonar type of view. So through that, we're able to look and identify, things, anomalies on the lake bed here. And as we've been traversing here so far today, we've seen a lot of really large sand waves that appear to be propagating off of the Keweenaw shoreline, and a relatively flat and smooth lake bed, which is very good for what we're looking for and what we're hoping to accomplish as we are looking for a missing aircraft on this survey. So there's a good chance that it's not in one piece, and we'll be looking for a debris field. So this very kind of homogeneous lake bed here should help us if there are any hard artifacts on the bottom. We'll get a good return that stand out in the data.
Yeah, that's great. Fantastic. And what many people may not realize, that I'm sure you do, because we're part of Lakebed 2030 together, only 15% of the Great Lakes has actually been mapped in high resolution. And we're part of a team that's trying to map the entire thing. But we know that's going to cost about $200 million and take about 10 years. So this little part that you're doing right now is really important, because not only are you searching for the missing plane, but you're adding to this large database of high resolution data that will be able to now generate new maps of the Great Lakes, which is really exciting for not just this mission, but the larger mission of Lakebed 2030 as well. Are you able, I don't know if you're on a computer or a mobile device, Travis, are you able to maybe show me and some of the viewers what the vessel that you're on right now, what you've got on your screen, and what the water looks like? Everyone wants to have a look at what the water looks like.
Yeah, absolutely. I'm going to switch spots here from the helm, and Chad Bonin from Ocean Infinity is going to take over for me. So behind me, you can see the helm of our survey vessel. And as I pan, we've got Chad here at the helm currently. He's one of our operators of the ASV, which is following its own line at the moment, so he can multitask. Hello. We've got James back here keeping tabs on things as well with the ASV. We've got Jessica right behind me from Kongsberg. She is watching the 2040 systems data as it's coming in. So she's actively looking for kind of these anomalies on the bottom here as we go. And then on the back deck, we've got Anthony and Allie, who are kind of discussing their next steps. So, and then I guess behind me once more is our Norbit. So we've got a large monitor here. This one is actually hooked up to the ASV over a remote desktop session. So we're using Google Remote Desktop. We have Starlink on this vessel, so we're connected on the internet here with this laptop. That is communicating with the laptop that is on the ASV, and I'm going to try to pan behind us, and you'll see through that window a tiny little dot on the horizon. That's our ASV. So we're being followed. We've got an armada going. We actually have one other vessel out here from MTU right now, and they're playing the role of chase boat for the ASV should we need to get on board and do any configurations or anything like that. But so far so good. We've been underway for the past several hours now, and conditions couldn't be any flatter and nicer out in Lake Superior. It is a bluebird day.
That's fantastic.
And I'm hopeful we'll have more of this week.
That's fantastic. Thanks very much for that, and good luck to you and all of the crew, science and operating the vessel on board today. I think we have the ability, we're just going to try this, we've tapped in to the computing system on the ASV itself. So let's just see, I've asked the producer here to put it up on screen. Let's see what happens. I'm telling my colleagues you can share your screen now, and let's hopefully we can see on this is the live stream. This is being broadcast on youtube.com/@realgloss. So the Great Lakes Observing System is live streaming this on YouTube, which you'll be able to watch it in the future as well. We have lots of subscribers, fortunately, and hopefully we're going to see the computer screen, but I don't see it yet. There we go. Okay, this is fantastic. So we're actually looking at the computer that's collecting the data on the autonomous surface vessel. That's what ASV stands for, out in Lake Superior right now. And it looks like My colleague has zoomed out a little bit so we can see the shore. They're transiting from the southern shore of Lake Superior out to the survey site. The survey site is about 20 square nautical miles. And my understanding is they should be there in a couple of hours. And if you can zoom in a little bit more, this is data that basically live data that's being collected right now as we speak. Now, you're maybe wondering, what are all those pinstripes? That kind of looks like a game of pickup sticks. That's because a multi-beam echo sounder transmits a fan-shaped wave of an electroacoustic pulse of energy. It actually illuminates with sound the bottom of the lake floor. And it does this like little tiny slices, and it collects these hundreds of thousands of pings over the course of a survey. And very frequently, you know, like many times a second, it's pinging the seafloor, and you can see it as it's advancing as we go. Now, Travis was showing you what the screen looked like when these get converted from these dots, really, because if we were to zoom in even more, they'd be tiny little dots. They get converted into an image that actually looks like the bottom of the lake floor. And that's essentially how multi-beam technology works. So the vessel is in the middle, but it has a very wide array. The deeper the water, the wider the array. It's a little bit like shining a flashlight on the back of a wall. The closer you are, the more detail you see, but the smaller the area. When you back up, the more area you see, but you get less detail. It's the same concept with multi-beam sonar technology. So they're going to be navigating to about 400 meters, 400 feet of water depth, I should say, where they have the survey site identified. Thanks very much to my colleague Mike and our friends at Norbit for making this possible. We are going to have more live stream tomorrow and the next day as this survey goes on. This is the first day where they're just transiting out to the survey site, and they're doing a lot of shakedown, I guess you could say. Is there anyone else? Maybe Travis, are you still there? Are you able to chime in? All right, we've got you back, Travis, and I don't know if you can see on the screen what I can see. I just gave an overview of what we're looking at on the ASV itself and the data that it's collecting. So it does look like it's moving into some deeper water. The lighter colors, so reds, yellows, greens, indicate shallower water depth, and then as it gets into the dark blues and the purples. So what is the water depth that we're looking at right now, approximately?
Yeah, I believe it looks like we might be at about 90 meters of depth currently. So you can see our transit line as we head due west from the north end of Portage Canal from the Keweenaw. And we came across sort of the shallow water depths there, and we are now kind of getting into the western basin of Lake Superior, where that dark purple appears on your map above.
Fantastic. Now, how long do you think it'll be before the ASV reaches the survey site?
Oh, I can tell you almost exactly about 15 minutes.
Okay. And then it's going to survey. And then when you showed us the vessel that you're on right now, I didn't see any cabins or sleeping quarters. Does that mean you're going back to shore tonight?
Yeah, that's the plan. So we'll be working some long days this week, kind of getting up with the sun and putting the boat away when it drops below the horizon. So we do have these longer transits, but we're collecting data coming and going on these transits, which is interesting because there have been pieces of debris from this wrecked plane that our state of Michigan marine archaeologist has confirmed are from this wreck. And our transit lines are going directly across some of the areas where these pieces of debris have been caught by commercial fishing nets, actually. So what we're doing is we're kind of following that debris trail to the west, which would be kind of up current. The western end of Lake Superior has sort of a counterclockwise flow to it. So through some of our forensics here, we're kind of speculating that the source of the debris, aka the crash site, is further west, which is where we're heading now.
Okay, well, that raises a question. Thanks for sharing that, Travis. We've got one of our viewers has asked, Mr. White has asked, what is one of the signs that wreckage might be located. And so if you do detect some wreckage, then how will you confirm that it is from the 1968 plane crash?
Yeah, that's a great question. So our first sign of something under the vessel would be watching the waterfall view, sort of like a side scan image, where we can human interpret what we're looking at, and in particular with this sonar data, the reflectivity of a hard object such as a rock or metal is a lot brighter in that waterfall view compared to the surrounding lake bed. So we are looking for these bright returns coming from the sonar, and these bright returns would, we flag them as targets. So should we see something that resembles a piece of debris, or something with very linear features, for example, that would be evidence of something man-made, we can flag that and go back over it at different angles using the same sonar equipment. We can also narrow the beam, the cone angle, essentially, of these systems to provide even a higher resolution scan over top of that target. And by doing so, we can make a decision if that's something that we need, that warrants further investigation with, say, a different piece of equipment. For example, a remotely operated vehicle, a underwater vehicle with a camera on it, that we could drop down to the depths and take a closer look. We also have other instruments such as a towed side scan sonar that we could deploy and basically do a pass, much closer to that object to get even more detail in that sonar image. And of course, if we see an X shape sitting on the bottom here of the lake, we're just going to go straight to a dive. And our state of Michigan marine archaeologist Wayne Lizardi, who you'll hear from throughout the week during these live updates, he's got his gear and is prepared to basically do an over-the-side dive to confirm any potential wreckage that we might find. And I guess to that last point, any wrecked aircraft is treated very much similar to a wrecked vessel in the Great Lakes. It is it's a part of the state bottomlands. It won't be disturbed, it won't be moved, it would not be recovered. However, what we're trying to do is document its location and condition, and try to provide as much of an answer as we can to that question of what happened, while preserving that wreck and that debris in the current condition we find it.
Well, and I imagine it would also provide some closure for the families of those who were on board that day.
Absolutely, and we've been fortunate to have been in contact directly with some living family members of the three deceased, and they're potentially watching this stream right now as we record, and very much looking forward to learning as we do what we discover in this search. So we're very hopeful that we can provide some answers, a location or some sort of evidence of where this plane might be and what happened. And if so, we'll certainly be reaching out to all the family members that we have contact information for and have already been in touch with.
Right. Well, and no doubt an emotional day. So our thoughts are with them, and our good thoughts are with you as well, Travis, and the crew on board, and the shadow crew, I guess, on the ASV, of which there's no humans on board because it's a robotic vessel, but all the people who are behind the scenes making this happen. We look forward to the updates throughout the week. You can catch them all here at the Great Lakes Observing System on our YouTube channel, youtube.com/RealGloss. And thank you so much for your time today, and the rest of the people on board with you. And we look forward to more updates tomorrow.
Yeah, thank you very much, Tim, and for everybody tuning in. We're very excited to be doing this mission, and looking forward to sharing it with all as we make forward progress.
Fantastic. All right. Well, safe travels, Travis, and good luck, and we'll chat again tomorrow.
Thank you.